Hello everyone. In this video, I am going to integrate TensorFlow Lite library on a PSoC-6 project through Modustoolbox. So the first step is to train a basic neural network model which predicts value of sine x given x. So let's get started. For training, we are using Google Colab. First, let's import necessary libraries. This includes TensorFlow for building our neural network, NumPy for numerical operations, Matplotlib for plotting our data and results, math library for functions like pi, Keras layers for defining our model architecture. Next, we are defining some key variables. N sets the number of data points we will generate to 1000. Val_r and test_r define the ratio for both validation and test data set, both set to 20%. Now we are generating our sine wave data. We set a random seed for reproducibility. Then we create x values uniformly distributed between 0 and 2 times pi. Y values are the sign of these values with a little bit of random noise added to make it more realistic. We then plot these raw data points to see what our initial data set looks like. With our data generated, it's time to split it into training and validation and testing sets. We calculate the split points based on the ratios we defined earlier. Then using NumPy's split function, we will divide both x and y values. Now we will plot these three data sets with different colors to visualize how our data has been partitioned. The legend will help us identify the train, test, and validation sets. So here we can see training set is larger than the validation and testing. Here we define our neural network model using Keras sequential API. It's a simple model with three hidden layers. First and the third hidden layers use ReLU activation, and the second layer uses swish activation. Each hidden layer has 16 neurons. Now we will compile our model. We are using RMS prop as the optimizer, mean squared error as our loss function because this is a regression problem. This is where the training happens. We call the fit method on our model, passing in the train data. We'll train for 100 epochs, but with batch size 16. So this may take some. The model is trained. We use it to make predictions on our test data set. We can then clearly see plots. Yeah. So this shows blue circle as the true one and the red circles as the predicted one. So let's see. Yeah, our model is quite well. Now we will convert this model into TFLite model. This is crucial for deploying it on microcontrollers or mobile devices. We use the TF-Lite converter for this and optimize it for the size. We then save it. Now the next step is to create a header file of this TF-Lite model. We use the xxd Linux command for this. Yeah, now everything we are all set. And now we can go to Modustoolbox for the further configurations. Okay, so now we have to download the sine model and sine model.tflite files. So let me do that. Save them in models folder. Now the next step is to move on to Modustoolbox and start a new application. You can choose any PSoC-6 board here, as we are going to use a template which is available on every board. So we can select for my purpose, I am selecting this BLE, and then we can go to Hello World. So now we can see sine wave demo. Then we have to go to main.c, and for sake of easiness, I have already uh, put the code on the GitHub. So I'm directly copying the code. I have also given the reason of every every statement in this. So I will give its link in description. So now we have to the first step is to rename the file to main.cpp. We do so because tflite libraries require C++, and we also move it to a new folder. Yeah, so now we are set from here, and then we can just copy paste these commands. These are the required macros for this project. Your project may be different. These are the global variables. This micro printf utility is required by the tflite micro, and was giving me an error, so I find a custom micro printf. And another HAL objects. Some function prototypes. The code explanation is written very clearly. This timer init function was also giving an error for me. So I have written a timer init. These it was giving an error of the order of these values. So I've just changed the order. All the else code is same. This ISR timer is exactly the same. There is no change. And now we just need to add these. Yeah, so now we are set on the coding part. Now we have to bring our models folder to this sine wave demo. So let me do that. I have this from here only. So I will just copy paste it. Yeah, so now I have brought, you can see there are only two files, sine model.h and sine model.tflite, which I downloaded from the Google Colab. And then what we have to do is we have to make some changes in the make file. Yes, before that we have to using this library manager, we have to add those libraries required like MLTFLite micro and ML inference and ML middleware. So let me add that first. ML inference, ML middleware, and ML TFLite micro. These are the required libraries for uh, integrating TFLM. Once you receive done, you can close this. And then we move on to make the required changes. So first I will change the app name to then we have to change the components. We need to add some of the components. Note that this step is very important. Then we have to include the directory of the models. We also need to define, and as we are using the C++, so we need to add this C++ flag. Yeah, and yes, we are all done. We can just save this. And now we are all set and we can go and build the project. Yeah, so our build is complete, and you can see that there are no errors and no warnings. So this completes our aim of the video. Thank you.